Hello, my wonderful students. Miss S here. Gonna talk you through protein synthesis again. You've had practice with this already, but I want you to have a video that you can watch and make sure that you understand it enough in order to say it back to Miss H or I during your test. That's what your test is. It's verbal. So let's work through this. The very first step of protein synthesis starts with your DNA in the nucleus, and it is going to go through transcription, which means that this gets split in half, and some little nucleotides are going to come and match up with their base pair. Let's stick it on this guy so we can move it easily. So base pairs, we have T bonds with A and A bonds with usually T. But because this is an RNA strand that we're building, it's going to have uracil, U, instead of T. That's one difference between DNA and RNA. So we have our DNA strand, our nucleotides are coming, and they are going to be building an mRNA strand. So these guys all bond together and match up, maybe. All right, do one more, and that'll be good. Okay, so there is your mRNA strand. Your DNA strand is your original. Your mRNA strand is your copy. So if you see a strand and you're not sure if it's DNA or RNA, you can see, does it have a T or does it have a U? And if it has a U, it's RNA. If it has a T, it's DNA. If it has a U, that is a copy of the original DNA strand. So that copy, that mRNA, is going to leave the nucleus and go into the ribosome, and your DNA is going to rebind together. It's going to close until it needs to do that again. So your mRNA strand is over here in the ribosome, and the ribosome is going to read 3 letters at a time. So AUG, 3 letters at a time is called a codon. Codon. So that's a codon. The ribosome reads 3 letters and says that I need a amino acid that comes from that code, AUG. So the amino acid will come, and it comes from a tRNA. So it's another RNA strand, but it's a transporter. He's not carrying a message, he's just transporting the amino acid. So the tRNA comes, he binds to the mRNA, they bond together, and they're a match, which is great, and so the tRNA's job is done. He is going to head off, he's going to leave and go off to go find another amino acid to bring back, because this is a continuous process. So we have an amino acid. So then the ribosome reads the next 3, CCU, and says that he needs the next amino acid. That one comes. The tRNA brings it along again. Those match up, great. So he drops the amino acid off and goes off to go find more amino acids. So that keeps going and going and going. The next step really is the mRNA is ultimately going to leave eventually. These little nucleotides are going to leave and go back to keep on coding. They're going to go back to the nucleus, because this is just a section of your DNA. There is so many strands of DNA that has to go through this process. So the mRNA is going to leave and go back to the nucleus and keep doing its job. So all we have left are these amino acids. And they're going to keep going and going and going until you have a big, long amino acid chain. And an amino acid chain is ultimately just a protein. So now we've built a protein, and this protein is ready to go off and do whatever it's designed to do. It could be to repair muscles, it could be to repair skin, it could be eye color, whatever it might do. Proteins do a ton of stuff, so that protein is done and ready to go off and do its job. So that's the process. I had transcription, where the mRNA wrote, or script, it wrote down what the message was, and then we translated it. That was the second step. So if it happens in the nucleus, if we're dealing with DNA and mRNA, that's transcription. If we're translating the code into an amino acid, that's translation. So hopefully that helps, and good luck on your test.